The size of an atom is ideally determined by the edge of its largest orbital. However, the conditions under which an atom exists must be specified to estimate its size. Atomic radius can be defined as 1/2 the distance between the nuclei of identical atoms that are bonded together. The trend to smaller atoms across a period is caused by the increasing positive charge on the nucleus. In general, the atomic radii of the main group elements increases down a group. Atomic radii are related to electron configuration. An electron can be removed from an atom if an element of enough energy is supplied. An ion is an atom or a group of bonded atoms that has a positive or negative charge. Any process that results in the formation of an ion is referred to as ionization. The energy required to remove an electron from a neutral atom of an element is called ionization energy or first ionization energy. Measurements of ionization energies are made on isolated atoms in the gas phase. This is to avoid the influence of nearby elements. Ionization energies of the main group elements generally increase across each period. Among the main group elements, ionization energies generally decrease down the groups. The energy for removing an additional second electron from an atom is referred to as the second ionization energy. The energy for removing an additional third electron from an atom is referred to as the third ionization energy. The second ionization energy is always higher than the first, the third ionization energy is always higher than the second, and so on. Adding electrons to atoms to form ions also involves energy. The energy change that occurs when an electron is acquired by a neutral atom is called the atom's electron affinity. Electron affinities generally become more negative across each period within the p block due to the addition of electrons to the p sublevel of atoms with increasing nuclear charge. In general, electrons are added with greater difficulty down a group. This is due to the fact that there is an increase in nuclear charge down a group, which increases electron affinities. It is also due to the increase in atomic radius down a group, which decreases electron affinities. Because it is more difficult to add a second electron to an already negatively charged ion in the gas phase, second electron affinities are all positive. When atoms become ions, their radii change. A positive ion is known as a cation, and a negative ion is known as an anion. The formation of cations always leads to a decrease in atomic radii since cations are formed from the removal of one or more electrons. The formation of anions, on the other hand, always leads to an increase in atomic radii since anions are formed from the addition of two or more electrons. Metals lose electrons to become positive ions or cations. Nonmetals gain electrons to become negative ions or anions.
Cationic radii decrease across each period, and anionic radii decrease across each period for elements within groups 15 to 18. There is an increase in both atomic and ionic radii across each group. Chemical compounds form because electrons are lost, shared, or gained. The electrons available to be lost, gained, or shared in the formation of chemical compounds are referred to as valence electrons. These electrons occupy the highest and incompletely filled main energy levels. The number of valence electrons in an atom of an element in groups 13 to 18 is equal to the group number -10. For example, there are 3 valence electrons in a boron atom. Since boron is in group 13 of the periodic table, atoms have different abilities to capture electrons. Electronegativity is a measure of the ability of an atom in a chemical compound to attract electrons from another atom in the compound. Fluorine, being the most electronegative element, is arbitrarily assigned a value of 4. Electronegativities tend to increase across each period. Although there are exceptions, the least electronegative elements are the alkali metals and the alkaline earth metals. Besides fluorine, the halogens, nitrogen, and oxygen are the most electronegative elements. Electronegativities tend to either decrease down a group or remain about the same. The atomic radii of the d block elements generally decrease across the periods. Ionization energies of the d block and f block elements generally increase across the periods.